The weight of what cannot be seen. Pick something up. Anything. A book, a cup, your own hand. It feels solid. It has weight. There is something there. And it's natural to assume that the weight you feel comes from the stuff inside, from the particles, from the matter. Let's go smaller. Everything you're holding, everything you are, is made of atoms. And at the center of every atom is a nucleus. And inside that nucleus are protons. So let's take just one, a single proton. It's unimaginably small, and yet it carries weight, real, measurable mass. In fact, almost all of the mass in your body comes from protons. So here's a simple question. What gives a proton its mass? At first, the answer seems obvious. A proton is made of smaller particles, quarks, 3 of them, 2 up quarks, 1 down quark. So naturally, you might think, add up the mass of the 3 quarks and you get the mass of the proton. But that's not what happens, not even close. If you do the math, if you take the known masses of quarks and add them together, you don't get the mass of a proton. You don't even get half of it. You don't get 10% of it. You only get 1%. Let that settle in. 99% of the mass of a proton does not come from the particles inside of it. So, where does it come from? To answer that, we have to look not just at what is there, but at what is happening. Inside a proton, quarks are not sitting still. They are in constant motion, relentless motion. They are bound together by one of the most powerful forces in the universe, the strong nuclear force. This force does something strange. Unlike gravity or electromagnetism, which weakens with distance, the strong force does the opposite. As quarks move apart, the force between them becomes stronger. It's like trying to stretch a rubber band that pulls back harder the more you pull. This means that quarks are never free. They're confined, held together in a constant dynamic tension. But this isn't a static bond. It is alive with activity. The space inside a proton is not empty. It's filled with energy, fields interacting, particles appearing and disappearing, gluons, the carrier of the strong force, flashing in and out, binding everything together. It is a storm, a constant, relentless, invisible storm. And here's the key. That storm has energy. And according to one of the most famous relationships in physics, energy and mass are not separate things. They are 2 sides of the same reality. Energy can become mass. So the motion of the quarks, the tension of the force, the activity of the gluons, all of that energy become the mass of the proton. Not metaphorically, literally. The weight you feel when you pick something up is mostly the weight of energy. Energy bound into structure, held in place by forces we cannot see. This means something remarkable. The solidity of the world around you is not primarily made of stuff. It's made of relationships, interactions, motion. The particles matter, but they're only a small part of the story. The rest is the invisible work of holding things together, and that work is not random. It follows precise laws, consistent rules, mathematical relationships that hold everywhere we look. Inside every proton, inside every atom, inside every object you have ever touched. The same pattern, the same order. And it's this order that makes the world stable, predictable, knowable. If the strong force were slightly weaker, protons wouldn't hold together, atoms wouldn't exist, matter as we know it would fall apart. If it were slightly stronger, everything would collapse into something unrecognizable. But it's not slightly off, it is exactly where it needs to be. And because of that, quarks bind, protons form, atoms assemble, stars ignite, and eventually, people exist. People who can ask questions, who can look deeper, who can discover that the mass of a proton is mostly something unseen. And maybe that realization invites a different kind of attention, because if most of what gives the world its weight is invisible, then what we see is only a part of what is real. And if what is unseen is ordered, consistent, essential, then it's worth noticing, worth studying, worth taking seriously. Because in studying it, we're not just learning how the world works, we're uncovering something deeper, a structure that holds, a reality that sustains, a pattern that does not break. And perhaps in paying attention to the pattern, we're doing more than observing. We are responding to a world that is not empty, but full, not chaotic, but ordered. A world where even the smallest things, even a single proton, carry within them a kind of hidden abundance, where almost everything that gives them weight cannot be seen, and yet is undeniably real. So the next time you lift something, feel its weight. Remember, you're holding energy held together by laws that do not fail. And notice that to trace it back, to follow the effects towards its cause, it is not just an act of science, but it can also be an act of worship.